This morning. Are we good upstairs with the stream too? All right. Those watching online, welcome as well. You missed out on the food. But we're going to start off with a word of prayer and then turn things over to Dr. Brand. All right. Let's pray. Dear Heavenly Father, we thank you again for this day that you've given us. We thank you for our time that we had this morning in discussion dealing with the topic of creation versus evolution. And we ask that you be with us this afternoon as we continue our conversation. Bless us and keep us. In your name I pray. Amen. And while Dr. Brand is making his way up, I know there will be a time for questions, so I will have the microphone going around. Please, please, please wait until you get the microphone, because we want the people online to be able to hear as well. They will only be able to hear his answer, not necessarily the question. So please wait till you get the microphone before you speak. And those who are online, you can text me, and I know we shared this at one of the tables, but if you want to send in a question, I'll try to monitor the Facebook stream and the YouTube one. You can text it on there or text me directly, and we'll try to get your question.
First of all, I'll mention that there are some books that I've written on this topic. This one, Faith, Reason, Earth History. This is used in a textbook in a number of Christian universities and colleges, including Adventist. This is you can buy the hard copy, or this is a digital copy is available online free. So you can just download that. You can download it right now on your phone if you want. And this is a smaller one that has some of the same types of information in a smaller format. Okay, taphonomy, catastrophe in the fossil record. Taphonomy, that's probably maybe the second new word you'll learn today. Taphonomy is the study of how animals or plants become fossils. So it's the whole process of fossilization, why some animals are fossils and some are not. And that's one of my areas of study. So we're going to talk about fossils this afternoon. In the modern world, dead bodies are recycled. Bacteria, scavengers, predators, they all take care of them. So the earth doesn't have a lot of accumulating, rotting flesh. And the fossil record has two categories of fossils. A lot of fossils are fragmentary and scattered. That's kind of what you'd expect when we see what happens to animals in the modern world. The other category, fossils that are wonderfully complete and very well preserved. That's an enigma. Why is that? Why would they be that well preserved? That's not what happens in the modern world. And so these wonderfully preserved fossils, that's an enigma that needs an explanation. Why did they not get destroyed by the processes that we see happening on the earth? Well, so let's look first of all, what kind of fossils do we get in the modern world? There are a few. One example would be there are certain kinds of traps and pits where animals get caught and get preserved. And primarily the La Brea tar pits here in Los Angeles and some other tar pits. Like you see here, that's a picture at the top of downtown Los Angeles when it was in much better shape than it is right now. There are the tar pits, animals that get caught in the tar, and they get preserved. And there are a large number of fossils preserved there in that tar. Animals fall into ice crevasses, but they don't really get fossilized. They get frozen. And if they thaw out, then they're not preserved. So that, I don't know if we can call those fossils. In Europe, in acidic peat bogs, they have found a few people that fell in several thousand years ago and were preserved in the acid peat. But, outside of that, fossils really don't form in the modern world, only under these very unique conditions. The fossil record from the ancient world is all in water-deposited rocks, water-deposited sediments, and that, I think, is very significant. When was a time when the earth was covered by water? That's where you find most of the fossils, the regular fossil record. Okay, let's look at some examples of these well-preserved fossils, and there are a lot of them. You see that crocodile in the upper left, and then a fish that's extremely well-preserved, dinosaur, and quite a variety of other creatures, and they're just beautifully preserved. They're articulated, every bone in place. See, when animals die today, they begin to rot. Insects eat them. The bones begin to fall apart. But that hasn't happened with any of these. They're beautifully preserved, and so we'll be talking about how that happens. Here's one is dinosaur. It's missing a few vertebrae in the tail. Otherwise, every bone is in place and just well preserved. It hasn't deteriorated like what happens today. So how did that happen? They had to have been buried very fast. So when animals die, we're going to look at some examples from the modern world. They disarticulate and rot and are recycled. And that's what normally happens. That's why we don't have the earth covered by rotting bodies. Okay, let's look at two examples. In Africa, there are wildebeest by the millions. It's really, I think there are too many wildebeest. They have to make long journeys to find food, and they have to cross dangerous rivers. And every year, many wildebeest drown. And some summers, 10,000 wildebeest drown in Africa. And then bison. We're familiar with bison in this country. They used to be in our country by the millions. But when Americans, when Caucasians came with their guns, most of the bison are gone. Okay? So just huge numbers of creatures here that have been died and been covered. So 10,000 wildebeest, we ought to have a great fossil record, right? Well, no, there are all the wildebeest bones. They've been, those years when 10,000 wildebeest died, there were biologists who studied those carcasses and find out what happens. They followed them year after year. All the wildebeest bones are gone in 7 years. The tissue gets eaten, the bones get chewed on and just deteriorated by chemical and physical processes. They're all gone in 7 years. The bison bones, millions of bison have been killed in this country, and yet there are very few bones even found anywhere, and they're not really fossilized. So what does this tell us? Well, somebody might complain, well, you can't compare wildebeest to everything else. Well, but what they tell us that there are no fossil wildebeest. Their modern environment does not preserve fossils. So contrast the wildebeest and bison with the fossil record we have. So let's look at a few more of those great fossils. The upper left, there's this coprolite that I talked to you about this morning. And then there are so many other fossils. They're just every bone in place, exquisitely preserved, wonderful bones. Well, most of us don't have a chance to see these fossils. Every year at the end of January, there's a fossil and mineral show in Tucson, Arizona. Dealers come from all around the world to sell their fossils. So if you have a chance, go to that Tucson fossil show, and you can see many, many fossils like these. There are many excellent fossils in this world. So, like I said, the predators and scavengers, they get rid of these things that die today. So let's look at some other examples of that. When we did research in Wyoming for some years, in the upper left, there's a cow, made a very foolish move. He tried to cross that cattle guard, and he got stuck. And this picture is a few weeks after he died. She died, I guess. The insects have already removed the tissue. Then in the next two pictures, over the next year or two, the bones gradually fall apart more and more until there's nothing left. In the lower left, you see bones. What happens to them? They deteriorate and fall apart. And so that's what happens today when animals die. The two other pictures are in Africa. Animals have been killed, and the tissue was eaten very quickly, and the bones won't last very long. So I have to come back to more fossils. They're so fascinating. These are pictures of invertebrates. Now, they don't have bones, but they have kind of hard external skeletons. And they're beautifully preserved. There's trilobites and crabs and a fossil invertebrate, excellently preserved. They're just wonderful. So we have to wonder, how does that happen? Why are they so well preserved? And look a little farther. Many of these are soft-bodied fossils. They don't even have hard external skeletons. They're soft tissue. Like in the upper left, there's a cricket, and then a flea. Can you imagine a flea that's completely preserved? On the right, on the upper part, there's a dragonfly. Now that's just soft tissue, and yet they're preserved. The one on the middle, on the left, I don't know if you can see that adequately. That's a fossil water strider. You know these water striders? We see them scooting around on the water surface. That one is big, several inches across. It's beautifully preserved. And then on the bottom, in the middle, there are dozens of insect larvae. Now, those are they're soft and squishy. They just don't last. And yet here they are, beautifully preserved. So the fossil record is amazing, what you can find there. And go back to Tucson and look at some other things. The individual fossils are just the beginning. There are many mass mortality layers that have been found and that are beautifully preserved. The one on the left is a lot of trilobites. And there are more of those. There are just many different kinds of things that are fossilized that way. Now these are not living environments with a lot of animals. Animals usually don't live in masses like that. These are creatures that have been brought together by water, carried by water together and preserved. So you've got, you got trilobites and clams and little starfish and shrimp. And you might think, well, I've picked the best ones. Well, no. There are many like these. These are small examples of huge masses of creatures died together. And every year, the Tucson show, they sell these. Then they bring more the next year. There's just a lot of these preserved this way in mass death assemblages. So, do these represent living habitats? No, they don't. Animals don't live packed together like that. These are transported assemblages, that is carried by water. When a lot of water flows rapidly, it has a tremendous power to carry things. And the flowing water also is effective in sorting items by size and shape and other features. We did research in Peru for a while, and there's one of the cities there at the base of the Andes called Ica. And this one year, there were floods coming out of the Andes, come down through that town, and it left a couple of feet of mud in the town. And people there in that town have a lot of taxis. They're little taxis called ticos. And during the flood, it sorted the things by size, and all the little ticos were in a pile of mud outside the town. It was kind of amusing. It wasn't amusing to them. But water sorts things, and that's what these are, is transported by water, by flowing water, and then buried very quickly. That's the key to all these well-preserved fossils. They have to be buried very quickly. So more of those mass death assemblages. There are just so many of these. So such excellent preservation, how does that happen? Well, if the radiometric time scale were correct, those millions of years of date, then many rock formations would accumulate at just a few millimeters each year, a little bit of mud each year for millions of years. Well, that's not going to preserve anything. That's not enough to bury them. Well-preserved fossils require burial at catastrophic speed. So what is the explanation for the fossil record? Death and burial by natural processes? No, not at all. Wildebeest bones gone in 7 years, and whale carcasses. We studied fossil whales, and on the lower right you see a fossil whale, and it shows what happens when a whale dies just out here in the ocean. People have studied that and studied what happens. The tissue is all gone in a few months. The bones get destroyed in a few years. So you cannot bury them slowly and be preserved. They have to be buried very quickly. And yet you see the one on the left, that's one example of many thousands of whales beautifully preserved in Peru. Okay, some people will say, well, the animals died in anoxic water. That means no oxygen. Deep water where there's no oxygen. Well, that's not a good answer. When an animal dies, the bacteria that break the animal down, they come mostly from inside the animal's body. And those are anaerobic bacteria. They don't use oxygen. And so there have been experiments that have showed that whether there's oxygen in the water or not doesn't really make any difference. The bacteria will destroy them quickly. So they have to be somehow protected from that. So I'm going to go now to one specific formation, the Green River Formation. And I talked about this very briefly this morning. The Green River Formation in Wyoming has millions of fossils. It's just amazing. And they're all preserved. You look at these things. That coprolite, and there's a bat, the oldest known fossil bat, every bone in place. And all these fish, everything, and little insect larvae, beautifully preserved. So how does that happen? The way all the geologists understand this formation is that the very, very thin layers of rock, I mean a millimeter or less thick, that those are annual or maybe one or a few each year. That's not going to preserve fossils. These had to have been buried very rapidly. I talked about this morning, this fossil coprolite, that is fossil poop. And yet it's preserved, it's buried in 180 laminations. That means if they're right about time, this thing lay in the bottom of a lake for a century. There's no way that happened. That had to have been buried very fast. There's a common model for how those fossils get preserved in the Green River Formation. The idea is there's a deep lake, and the water in the bottom is anoxic, has no oxygen. And animals sink down in there and they get preserved. Now, the paleontologists really have no excuse to think that, because there have been a number of publications showing that being in water with no oxygen does not help to preserve them. Well, one of our graduate students tested this theory. There are several lakes like that in eastern United States, with deep lakes with no oxygen in the bottom. And he would take a boat out and sink a dredge down and get samples of sediment from the bottom to see how many skeletons there were there. Okay, so what did he find? No skeletons, no bones. Nothing gets preserved in those lakes. So that's a joke. That theory just doesn't work. No skeletons, no bones. There's no alternative to rapid burial at catastrophic speed to make fossils. And there are actually many vertebrate fossils that are not complete, like that whale was. They have fallen apart. The bones have disarticulated, like you see here in this picture, the upper one on the right. The bones have fallen apart, but even those are beautifully preserved. They have not disintegrated like what happens today. So something interesting is going on here. Some dinosaur bone quarries. There are a lot of quarries where they dig up dinosaurs. And researchers report that when they first dig into these masses of dinosaur bones, there's a strong smell of death. That is a smell of decay. Millions of years and it still smells like decay? No, that's not possible. This all happened very, very rapidly. And many of those fossils, way down on the fossil record, have protein in the bones. Now this is something that paleontologists argue about a lot because that's an enigma for them. Chemists know that proteins don't last millions of years, a few thousand years at most. And yet fossils that are supposedly 200 million years, 500 million years old, have tissue, have protein preserved. So what do they do with that? Well, they argue about what to do with it, but in fact it requires very rapid burial. Here's a diagram from the literature. This is a common portrayal of how fossilization occurs. And so they show this dinosaur dies, his skeleton is lying in a riverbed, he gets buried gradually, and in their understanding this is over millions of years. And then we dig up the bones. Well, this is how they portray it, and this is the way they have to portray it. They have to think this could happen. But that is highly unrealistic. There is no way that's going to happen. That dinosaur laying in a riverbed, he's in the same situation as those drowned wildebeest. His bones are going to be gone long before there's any possibility of them being buried and preserved. And so they believe this because they have to believe it, but it doesn't work. There's no alternative to rapid catastrophic burial. And just how rapid, we really don't know, but very rapid. And let's look at this a little further. There are a lot of bones that are very small that are found, like the ones on the bottom. You're just a centimeter or less, or a few centimeters. They're just tiny, but yet they're still beautifully preserved, the individual bones. That still requires very rapid burial. So how does scientists deal with that? Well, something is wrong. They didn't get deteriorated the way bones do today in the modern world. There are so many fossils, from dinosaurs on down through little tiny things, and they're like that typically, many of them, so well preserved. And so what do we do with this? Well, in the modern world, animals normally do not get fossilized. They deteriorate, they're destroyed by scavengers and bacteria. They don't get preserved. And so how do we explain the fossil record? Well, fossils are formed during catastrophes. They have to be quickly buried and preserved, so it has to be some kind of catastrophic situation. And the typical paleontologists really do not recognize this. That they can't, because they believe firmly in millions of years, so somehow they have to explain it. But yet they really don't have good explanations. Even those modern catastrophes are not adequate. I would say that the only catastrophe adequate to produce the fossil record is the biblical flood. Now, this would be heresy among most scientists. They would laugh at this idea, but in fact, that is the only explanation that can explain the fossil record that we have. So you have to do it at catastrophic speed, and this is the only catastrophe adequate to do the job. So that's very strongly in favor of our understanding, our biblical understanding of geology and paleontology. Fossils and much other evidence says the long age theory with its millions of years just is not adequate to explain the evidence. I like this comparison. To try to explain the geologic record and the fossils by the standard model is like trying to win a race with an ox cart when the only thing that is adequate is a Ferrari. So I guess the flood was our Ferrari that did the job. So that's the only explanation that works. Thank you.
Are there any canyons like the ones in Nevada, Grand Canyon?
Grand Canyon?
Are there any like that over in Africa or Eastern Europe?
There is, okay, there are canyons that are that big. There's even a canyon that big just in the ocean, just off our coast. But there are big canyons in Africa and other places. In so many of those countries, there's too much vegetation and other things that make it hard to see what's in the rocks. So the Grand Canyon is kind of unique in that sense. It looks to me like when during the flood, God preserved an area here in western United States for the benefit of geologists, because the rocks are so well preserved, and there isn't all this green stuff, plants that cover up the rocks. And so it's ideal for studying them, and that's what we do.
So when I went to the Grand Canyon, I think they have like that diagram inside the museum or something.
Yeah.
And I think they use that a lot for evolution, like to prove it, because I guess the different layers of the sediment show the different, like there's ferns for 1 century to show, because they believe ferns are like the first plants to be yeah, they're like the bases. So then like what would that look like? Because they're kind of using that to argue against creationism. So it's like, then there's like the next evolutionary critter that goes up.
Okay, so the layers of rock with different fossils in them. And I talked a little bit about this concept this morning. They will say that this is evidence for evolution. What we need to understand is when you're dealing with the ancient past, we were not there to see what happened. And so science, a study of the ancient past, has to begin with assumptions. And only after you make the assumptions, then you use those to try to explain your evidence. And so those layers of rock, if it formed over millions of years, you'd have layers of rock, but they really would not look like the layers that we have. The layers of rock that we have are better explained by a catastrophe that spreads sediment over hundreds of square miles. And so the evidence actually fits creation and the flood better. But they've decided that they don't accept Genesis, and the scientific community in general just doesn't accept that. They've decided to explain it by millions of years of evolution. And so that's the way they explain the evidence. So they're giving you an explanation that fits their theory. We also have explanations that are different and really better, that fit the evidence better.
The moon is just plastered with meteors, smashed all over it. So to say that we might have one coming close to us in 2032, that could knock out a city, if it does hit us, if it does hit a city. Could a meteor cause a fossil?
Could a meteor? Well, it could bury something quickly. That's a possibility.
Because we do have craters in South America.
Yeah.
And
But, yeah, there's evidence that during the flood, there were meteorites hitting the earth. And so, yeah, it could, the only way it could preserve a fossil is it sprays out a lot of sediment that very rapidly covers it. So that's might help, probably would not be adequate to do it. There were meteorites during the flood, and one could hit us now. I mean, we don't know, but there's way too many fossils spread over the whole Earth for that to be the explanation for most of them. Maybe a little bit could happen that way.
Are the agings of the fossils around the world the same time? Or are we seeing fossils at a certain area of the world aging at a different time?
Well, okay, the age around the world is the same. What difference is you find layers of rock, one above the other, and so they'll give, if you use the radiometric dates, the ones at the bottom would look like a different age than the ones at the top. But there's a lot of evidence to say, though, that dating method doesn't work. It doesn't give you good dates. So it looks more like, to me, like this was all during the flood, very rapidly.
I have it's like two questions because I wasn't here for the earlier part of the day. Did you discuss anything about carbon dating?
No, I didn't in detail. I'll just say a little bit about carbon dating is one method of a number of methods of radiometric dating. And those are the primary evidence that people use for the millions of years, radiometric dating. And and carbon-14 is just one of those methods. That's the method they use that tells them the millions of years. And, that's, what do we do with those dates? Well, in the first place, that's one line of evidence. That's the one that they primarily rely on. But there are a number of other types of evidence that are just incompatible with those dates, with those long dates. And these fossils are one. The fossils say that it cannot be millions of years because fossils have to be buried much too fast for that to be true. There are other types of evidence. And we don't have time to get into this, but the way the rock layers are deposited on the earth, it has to be catastrophic, not very slowly. And so, I can't prove to you that those dates are wrong, but there's so much evidence in addition to the Bible that says those are not right. So I think those are wrong.
And my second question is that there's an ancient theory that if you look at all the continents, they fit into each other.
Yeah.
South America fits into Africa and all that sort of thing. I think it was
Continental drift?
Pangea, when everything was one.
Yeah. Pangea. Yes.
So then I'm sure the flood had something to do, I'm not sure, but could have had something to do with the separation of the continents. Is there any evidence, like fossils, of things that should not be in a particular area? Like a fish or something that's native now to, let's say, Asia, that's in the fossils in the Grand Canyon or something like that?
Okay, your first question, these continents moving around the earth, is that real? Yes, it is. There's abundant evidence for that. And it looks to us like this movement of continents is really what what happened at the beginning of the flood. I believe there's something, I don't know what caused it. Maybe God caused it directly. But anyway, the earth's surface started breaking up. And this, I believe, is what brought on the flood and was one of the main things that happened during the flood. And it looks like when these continents started to divide, now you have a continent splitting, and the water is hitting very hot magma, which is the rock under the surface of the earth. And that would cause tremendous amounts of steam, which could account for the 40 days of rain. So yes, there was continental drift, and it fits very well into our understanding of the flood. Did that affect the fossils? Well, it did in one respect. Where it looks like Africa and South America were together, they have moved apart, so now they're far apart, but they used to be close together. And there's some kinds of fossils you find in Africa, in South America, where they would have been together. Those deposits would have been together. Now they split apart. So that really is very much true.
Did anyone else have a question? Well, I was gonna say to that point as well that one of the ways that the scripture describes the flood is not just rainwater, but also water and geysers from beneath, kind of describing whether it's underground volcanoes or eruptions going on that are contributing to